Today we're going to learn how to make equivalent fractions. As you can see up here, we can make equivalent fractions by multiplying the numerator and denominator by the same non-zero whole. If you multiply something by 0, you get 0, and so that's why, the definition kind of says non-zero whole. But you might be wondering, in equivalent fractions, equivalent fractions are different fractions that have the same value. For example, if a cake is divided into 6 and you, being incredibly hungry, ate 3/6 of that cake, 3 out of the 6 pieces. Let me just see if I can draw. Bear with me here. Well, kind of a funny lopsided cake, but it's in 6 pieces. And you ate 3 of those pieces. You might recognize we can make another fraction with that. You ate half the cake. These are equivalent fractions. They're different fractions. This one doesn't use the same numbers. This one says 3/6. This one says 1/2, but they have the same value. Okay, I'm going to erase this, and next I'm going to put up the steps. What I think are some of the easiest steps to find equivalent fractions. Because before you can add fractions or subtract fractions, they need to have the same denominator. And so that means we need to convert fractions into equivalent fractions. After we talk about the steps, we'll do some examples. Okay, the first step. List multiples of the denominators. Let's say you want to add 1/2 plus 1/3. Well, we'll just stick with that right now. You want to list the multiples. Okay, so list the multiples of the denominators. I'm going to start with 2. 2, 4, 6, 8, 10. I could have stopped earlier, but I don't know why I didn't. Now let's list multiples of 3. 3, 6, 9, 12, 15. Okay. We listed the multiples. Next step, find the same number in each list. Lowest is easiest. Well, let's look in the list. Do we see any numbers here that are also in here? And I'm going to add one more on here just so that you can see it. Because right now we have a couple numbers that are the same. There's a 12 here, there's a 12 here. But lowest is easiest. Is there something lower that's in both columns? Yes, there is. There's a 6 in both columns. That number can be a common denominator. Okay, so to convert, we have to convert both of these to find a common denominator, before we can add them together. So let's start with the 1/2. Let me put our check marks here. Multiply existing denominator. I should have said numerator and denominator. I'm going to have to fix that. And numerator to get that denominator. Okay, 1/2. I'm obviously going to have to fix this. I hope it still makes sense. 1/2. We want to convert it into something that has a denominator of 6. So 2 times what equals 6? Well, hopefully you know your 2's. If not, no worries. We've got our chart here. 2 times 1 is 2. 2 times 4, or 2 times 2 is 4. 2 times 3 is 6. And if we're multiplying the denominator by a 3, we need to multiply the numerator by a 3. because essentially we are multiplying by 1, because 3 over 3, if you have a circle, a pie with, with all 3 pieces shaded, you've got a whole pie. So what this does is it helps us to find an equivalent fraction, a fraction that has the same value with different numbers. Okay, 1 times 3 is 3. So now we know that 1/2 equals 3/6. Now let's convert the 1/3. 1/3 times something is going to have 6 as the denominator. Let's go back to our chart. Here's the 6. What are we going to multiply 3 by to get 6? Well, that should be pretty easy because we just did it. We did 2 times 3 is 6. And if 2 times 3 is 6, 3 times 2 is 6. Or we could do over here. 3 times 1 is 3. 3 times 2 is 6. Find it either way. We multiply the denominator times 2. We also multiply the numerator times 2. 1 times 2 is 2. In the interest of space, I'm going to erase this so we can now add these together. Okay, so instead of 1/2, we have 3/6. They have the same value, different fractions. Instead of 1/3, we have 2/6. Same value, different fraction. And again, we could illustrate that. We've got 6 pieces here. Let's see. This would be 2/6. Let me draw another one to compare. When I draw 6/3, I like to put a circle in there, and then I go down to my circle, and then I make 2 legs. So 1/3. Well, my drawing's not exactly accurate, but 1/3 equals 2/6. Now, because we have common denominators, we can add them together. Denominator stays the same. We still have 6 parts. We add the numerators. 3 plus 2 equals 5. That is one reason we care about finding equivalent fractions, so that we can do our arithmetic, so that we can do our operations. We can do our adding and subtracting. We have to have the same denominator. To find the same denominator, we make equivalent fractions. And now you know how to find a common denominator. You know how to make equivalent fractions.